Hello and welcome back to this chemistry revision series brought to you by revisedchemistry.uk.
The first equation that we're going to try and balance is H2 plus F2 makes HF. If we draw each of these molecules out as bubbles, we will see that there are two hydrogen atoms on the left hand side, two fluorine atoms on the left hand side, and one hydrogen and one fluorine. We can see that there are only two hydrogen atoms on the left, where we make one hydrogen on the right, two fluorines on the left, while we only make one fluorine on the right. The law of conservation of mass says that we cannot create nor destroy mass, so we have to start with the same number of atoms as we finish with. As I can't change these small numbers, as that would change the number of atoms in each of the molecules, all I can do is multiply how many of each molecule I have. To balance this equation, all I need is another molecule of HF. That shows that we have two molecules in our products of HF, so we must change our equation to reflect that. Another way to balance this equation is to use the grid method. The grid method involves writing down which atoms you have on the left-hand side and writing the total number of each element on the left-hand side of the reaction and on the right-hand side. For hydrogens, on the left there are two, and on the right there is one. For fluorines, on the left there is two, and on the right there is one. To balance this equation, we need to have the same number of each atom on the left as we do on the right. As I've said before, we cannot change these small numbers next to H2 and F2, and I cannot add small numbers into HF. All I can do is multiply how many of each molecule there are on the left or the right hand side. To get both hydrogen and fluorine to two atoms each on the right hand side, if I multiply HF by 2, I end up with two hydrogens and two fluorines. The final way to balance an equation is to use the number method. This method is only really useful if you find balancing equations already quite easy. The way that we use the number method is to look at how many atoms of each element there are on the left and move sequentially along the equation until we have the same number as we do on the right hand side. So to start with, there are two hydrogen atoms on the left and only one on the right. If I times this whole molecule by 2, that satisfies the need to have two hydrogens on the left, as it does to have two hydrogens on the right. We've got two fluorines on the left, so let's try and balance that on the right, and we can see through our process of trying to make hydrogen balanced, we've also made fluorine balanced. Fe, iron, plus chlorine makes iron chloride. First of all, we can try our bubble method. Fe plus Cl, Cl makes Fe, 1, 2, 3. We can see that we have one iron on the left and one iron on the right. We can see that we have two chlorines on the left, but three chlorines on the right hand side. To balance this equation, we're going to need to make sure that we have the same number of each atom on the left as we do on the right. This isn't just a case of multiplying 1 by 2. Unfortunately, we do not have that luxury with this equation. And the bubble method here is quite difficult for us to be able to see how we could balance this. The better method for this equation would be to use the grid method. On the left hand side we have one iron, and on the right we also have one iron. However, on the left for chlorine there are two, and on the right there are three. To make this balanced, we need to have the same number of chlorines on the left as we do on the right. We have to times both of these numbers by different values to have the same value of chlorine on both sides. If I times this value of chlorine by 3 and this value of chlorine by 2, I will satisfy my need for the same number of chlorines as I have on both sides. If I times this chlorine by 3 and this whole molecule, basically this chlorine, by 2, I will end up with 6 chlorines on the left hand side, and I will end up with 6 chlorines on the right hand side, because 2 times 3 is 6 and 3 times 2 is 6. I also now have 2 iron atoms on the right hand side. So I must change that in my calculations as well. So I can redraw this as FeCl, Cl, Cl, and I also have another Cl here, and I have another Cl here. The bubble method doesn't really work for large changes in atoms. The only thing that I need to change now is my iron value, because I have 2 on the right hand side and only 1 on the left. By changing this to a 2, my equation is now balanced. Let's try an even more difficult equation now. So sodium sulfate plus calcium chloride makes calcium sulfate plus sodium chloride. The grid method is our best bet to being able to solve this balanced equation. Sodium, sulfur, oxygen, calcium, and chlorine atoms are all involved in this equation. There are 2 sodium atoms on the left hand side and 1 sodium on the right. There is 1 sulfur on the left and 1 sulfur on the right. There is 4 oxygens on the left and 4 oxygens on the right, 1 calcium on the left, 1 calcium on the right. There are 2 chlorines on the left and only 1 chlorine on the right. So first of all, we can see that there are only 2 different elements that are not balanced in this equation. There are 2 sodium on the left and 1 sodium on the right, 2 chlorines on the left and 1 chlorine on the right. The easiest way to solve this is to just put a 2 in front of sodium chloride, and that gives us both of these balanced. This equation looks quite complicated, but actually there was only 1 step involved to make this balanced. How about then the combustion of ethene in air? I've set this up so we can use the grid method, so why not pause the video and see whether you can figure out how to balance this equation. There are 2 carbons on the left hand side and 1 on the right hand side. There are 4 hydrogens on the left and only 2 on the right. We have 2 oxygens on the left and 3 on the right. Starting with carbon, we can simply times carbon dioxide by 2 to make our carbons equal on the left and on the right. But we've now got 2 lots of carbon dioxide, which means I've got 2 lots of 2 oxygen, plus the 1 from water means that in total I have 5 oxygen atoms. Hydrogen, 4 on the left, but only 2 on the right. So if I times this whole molecule of water by 2, that means I end up with 2 lots of 2 hydrogen atoms, but also 2 lots of oxygen. So in total I have 2 lots of 2 from carbon dioxide, 2 times 2 is 4, but I also have another 2 from water. So in total the amount of oxygens I have is 6. On the left hand side I only have 2 oxygen atoms. So if I times my O2 by 3, I end up with 6 oxygen atoms. This equation is now balanced. The final question we'll look at is between aluminium and oxygen to make aluminium oxide. Pause the video now to see whether you can balance this equation. On the left hand side we have 1 aluminium atom and on the right we have 2. On the left there are 2 oxygen atoms, whilst on the right there are 3. The first step might be to balance the aluminium atoms, but we'll leave that for now because we're going to come back to that a little bit later. Because there are 2 oxygens on the left and only 3 on the right, we can't multiply just one of them by one number. We're going to need to multiply both of them by different numbers. Timesing 2 by 3 makes 6, and timesing 3 by 2 also makes 6. So this is the logical step for us when balancing this equation. So if I have 3 lots of O2, I'll end up with 6 oxygens, and if I have 2 lots of aluminium oxide, I will end up with 6 oxygens. I also end up with 2 lots of 2 aluminium, which is 4. 2 lots of 3 makes the 6 oxygen atoms. Because I'd only have 1 aluminium on the left but 4 aluminiums on the right, I put my 4 in front of aluminium and now my equation is balanced. If you'd like to see more balancing equation videos, then please leave a comment below. Until next time though, thanks for watching.